everyone. In today's video, we are going to see model for network security. This is one of the most important topic in the network security or information security, and the complete working principle will be the reason behind the communication between sender and the receiver. That means the whole process, how the information will be shared or sent from one end to other end will be completely dependent on this model only. So let's see the theory part first, and then I'll explain with the example. That means the network security model. What happens is, in this model for network security, the data will be transmitted over the network between the sender and receiver only when the sender and receiver has a mutual cooperation to receive the data or to send the data. So a logical information channel will be in between the sender and the receiver, which will pass the information from the sender to receiver through the internet by use of communication protocols. So these communication protocols are used to transfer the data from one end to the other end, that is from source to destination. So what happens is, whenever an opponent presents in between the logical channel or in between the message transfer, then that will be a threat to confidentiality or authentication or integrity. Okay, only when an opponent is present. If no opponent is present, only the information is being passed with the trusted parties, then no threat will be for the message or for the information. Okay, now this security related transformation about the information will be unreadable. That means whenever we are sending the message or information from the source to destination, it will not be transmitted as it is. So depending upon the algorithms, or using some digital signature, or using some ciphertext, they will encrypt the message. That means they will change the readable format of the message to the non-readable format, unreadable format. Okay, we can't read that message. So that between the sender and receiver, some secret information will be shared, just to check that okay, this information is valid or not, or any opponent is changing the information in between or not. So this complete entire process, whatever we discussed till now, what are the threats do we face when the information is being passed from one end to the other end. So all those things will be covered in this model. That means how the process will be going on and how we have to avoid them and where we have to avoid them. So what happens is, whenever a trusted party is needed to achieve the secure transmission, that means whenever a transmission must be very secure, then they should follow some basic principles. So we'll see that principles as well. First, let me explain with the diagram for the model for network security, and whatever I explained till now, it's all in the theory part here. You can just make a note of it as well. And now let's see this model for network security. Okay, first remember, this message and this messages are same. This is sender and this is receiver. Okay, whatever the message you are sending, that message should be received by the receiver as well. So both these messages will be same. Okay, this is the first point. And then secure message, and whatever the message here and whatever the message here will be same. Okay, this is sender side and this is receiver side. So these two messages will be same and these two messages will be same. And we have discussed there will be one logical secure channel to transmit the data from sender to receiver. So this is that. Okay, secure logical transmission channel. And I said opponent, and here the opponent will try to attack the data, or it will try to get access to the data. And I also discussed trusted third party and all the principles they have to follow to make sure that there will be a secure transmission of data. So the trusted third party and the opponent, they will be on a same length or same ratio. They will be on the opposite side in the sense that doesn't mean when the data is going here, trusted party will be here and opponent will be only on this side. That's not what I meant. They will, their acts, their services will be completely opposite. One will try to hide the data, secure the data. One will try to modify the data. They'll try to desecure the data. So that is what I meant. Opposite means. Okay, now first this is secret information, and this secret information will be same. Sender side secret information, receiver side secret information. Now for what will happen is, when a message is sent from the sender, a secret information will be attached to that message. For example, let's take a small text here. Okay, we are sending hello. Okay, this is actual message what the sender want to send. Now a secret information will be added. For example, we will add U V W. Okay, enough. It doesn't mean that it will be added only at the end. It can be at the beginning, or it can be appended or in between these letters, or it can be added as padding bits as well, so that secure message and the secret information will be depending upon the principles of the trusted third party. That means I told that they have to use some algorithms, they have to generate secret information using those algorithms. So based on those four principles only, the secret information will be decided, like where it should be placed and how it should be placed, all those things. So we will see that later. And once this secret information is appended, now this is secure message. That means that cannot be hacked easily. Now that message will be transferred here, and this is a channel. That means here network. For example, the sender is in some Mumbai, receiver is in Hyderabad. Okay, so to transfer the data from Mumbai to Hyderabad, there will be a network. Okay, some channel. Imagine that as this channel, logical channel, which is secure channel. And now what happens is, the trusted third party, whatever we are using, they will make sure that this network will not be modified. I mean, this data which is going through this network will not be modified by hackers or opponents, and they'll make sure that this information is not readable. That means we can't understand that message. Okay, that will be changed to some other form. It depends upon the algorithm as well again. This is the working of trusted third party. Now what is the working of the opponent? This is a kind of hacker. Okay, he or she will try to modify the data, or they will listen to the data, or they will try to get access to the data. So all those things will be done by this opponent. Okay, once that secure message passes this logical channel, it reaches to the recipient side. So now here what are the messages received? They will store the message, and now they will decrypt the message. That means they will change the not unreadable format to the readable format. So while doing that, this sender and receiver will have same algorithm that will be not published to anyone. So that will be kept secret. So using algorithm, they will generate the secret information, and using the same algorithm, they will find the what will be the secret information. So before checking the what is the secret information here, first they will just generate secret information using the algorithm. So they will use some algorithm, and they will get the information, secret information, as UVW. Okay, now what they will do is, they will take this secure message. What is this secure message? In our case, hello UVW. And now they will know that, okay, the secret information will be appended to the actual text at the last, and that should be UVW. They will check whether it is there in the actual text received or not. Okay, it is there. So this is correct only. This is not modified data. Now whatever the remaining thing, that is the actual message. Now from here to, they will send the actual message to the recipient in the Hyderabad. This is how the information will be passed from one end to other end. So this much of process will be completed between the sender and the receiver. Okay, Now I have told you there will be some principles to generate this secret information, right? So they are, first, design an algorithm. So whatever the algorithm, one type of algorithm will produce one type of secret information, and depending upon the algorithm, the security will be different. This is for security. Okay, algorithm same, sender side should be same algorithm, and receiver side also it should be same algorithm only. Okay, and after that, using that algorithm, they will generate some secret information which should be used to say, used with the message here. Okay, after that, they will develop some methods for sharing the secret information. That means they will find some methods to identify the secret information on the receiver side. Then they will use a protocol to be used. That means they will they will specify the protocol. That means using one protocol, and we will get one kind of data. Using the other protocol, we will get the some other data using only one algorithm. For example, I'm using RSA algorithm. Okay, using RSA algorithm, and I'm using TCP protocol or any other protocol, that depends upon the sender and the receiver, or that complete network security system team. Okay, using RSA and TCP protocol, they generated secret information to append is UVW. Okay, I'm using SHA algorithm, and I'm using the protocol HTTP, and I got information as XYZ. So depending upon the algorithm, depending upon the protocol, the secret information will vary. That is why no one will say what kind of algorithm is used and what kind of protocol is used in the transmission between the sender and the receiver. Okay, this is what, how the complete process of the information transferring from the source to destination. Thank you.